This screencast is on Chapter 32, the Digestive and Excretory System. So it's basically how you get your nutrients, it's how you process it, so that you can maintain homeostasis. There are 6 types of nutrients, and the most important one is probably water, because your body is mostly made up of water, and water is a good solvent, and it's involved in every chemical reaction in the body. It helps you digest food, eliminate waste, maintain your blood pressure, regulate body temp, and then it keeps your skin moist. Carbohydrates, we discussed this fall semester. Carbs are important for energy. Eventually your cells will break down these macronutrients into ATP, which your cells could use. You also have proteins, and everyone knows about proteins. It helps you build muscles. And proteins are also enzymes. Enzymes help speed up chemical reactions. There are essential amino acids which can't be made by your body, so it has to be consumed from outside sources. Fats provide energy. Your body can also store it for later use. And they're also the key components in cell membranes. If you recall, the cell membrane is constructed of the phospholipid bilayer. So it's important that your body can make some of these fatty acids and that you consume it from the foods that you eat. Minerals are like trace elements or major elements, things like calcium, phosphorus, potassium, sodium. I know for sure potassium, sodium, and chlorine are used in triggering nerve signals. It's called the action potential. We went into this a little bit during the nerve and endocrine system unit. So those are major elements that your body needs to perform. And then you also have trace elements, things like manganese, iodine, which prevents goiter, and then zinc and iron. So iron is a component that's found in hemoglobin, and hemoglobin is in your red blood cells, and it helps bind oxygen. So again, you need oxygen because your cells perform cellular respiration. So all of these body systems, these organ systems, they're all interconnected. They all depend on each other. You can't think of these as isolated systems that perform on their own. And the last type of nutrient that your body needs to either absorb or produce are called vitamins. So these are helpers for enzymes. They help the enzyme do their job of cell function, growth, or development. It's probably not too important that you memorize what's fat soluble and water soluble, but I'll just explain. Vitamins A, D, E, and K can be stored in body fat for future use. And then vitamins C and B, so citric acid, which is found in orange juice, and then vitamin B, which are found in meats. These can't be stored, and they are excreted in urine and fecal matter. And here are a few examples of diseases or consequences of not getting the right types of nutrients or vitamins. So the top left right there, that's scurvy. That's caused by a vitamin C deficiency, which causes inflammation of the gums. And sailors eventually found out that if they had limes on board and if they consumed those limes, it would prevent scurvy. Bottom left is called chylosis. You can see the fissures of the lips, and this is due to riboflavin deficiency, which is not getting enough vitamin B. The child there with bowing of the bones, that's called rickets, and that's due to vitamin D deficiency. So it has to do with absorbing calcium, which allows for your joints to grow properly. And then top right, that's called goiter, which is caused by an iodine deficiency. So when you go to the supermarket and you buy your salt, it's going to say iodized salt. So a little bit of iodine has been added to it so that you're getting this mineral. And if you recall, your thyroid, which is a part of the endocrine system, is located in your throat. So if you have any sort of iodine deficiency, you're going to come down with this condition. And again, it's called goiter. Meeting nutritional needs supports good health. So it's important to eat a balanced diet. Now, your energy consumption is measured in a unit called calories, and this is found on the back of every nutritional label, and it also gives information about the foods that we eat. So up here in this top left corner, you can see the calories per serving. And again, the average adult probably needs around 2,000 calories depending on the person and how active they are. Teenagers probably need more than 2,000 calories. If you're playing a sport, anywhere between 2,500 to 3,000 if you're a girl, and probably 3,000 to 3,500 calories, maybe even more, depending on the sport if you're a boy. So as you go down this label here, you could see how much fat you're getting, sugars, fiber, proteins, it tells you on this label here. Now, do understand that fats actually provide the most energy per gram. So fats will give you about 9 calories per gram, whereas proteins and carbs will give you 4 calories per gram. And this makes sense because if you think back to, ancient times, your ancestors, they're hardwired, and you're hardwired to desire foods that are rich in fat and oil content because it actually provides more energy. So before the modern world, where you had to forage for food or go hunt an animal, it was probably in your best interest, or it would benefit you the most if you went after foods that were high in fat content as opposed to foraging for berries in the hot sun and spending all day just to get a minimal return on your investment and your efforts. So that's why you salivate at the thoughts of foods that are rich in fat content, things like French fries and hamburgers, as opposed to salads and berries. They don't quite have the same effect on you. So here's an overview of the digestive system. So as you can see, there are several organs that are working together to help break down food. And I'll just give you a quick rundown from top to bottom. Your digestion is actually going to start in your mouth. This is where mechanical digestion occurs. So mechanical, almost like machine-like, where you're chewing and you're breaking up the food. Okay, you're using your teeth to gnash and to grind up your food so that it becomes smaller. Now, underneath your tongue, you have a few different glands. You have your parotid, your sublingual, and your submandibular gland, and these secrete saliva. And your saliva contains an enzyme called amylase that helps break down carbohydrates. So again, carbohydrates are long chains of sugars, and your body can't process all of this at once. It has to be broken down into tiny bits with the goal of using these nutrients in cellular respiration, and then ending up with ATP, which is a form of cellular energy that the cells could use, right? Because if you just eat a big cheeseburger, you can't use protein, and you can't use fats, and you can't use sugars right away. It would be like kind of opening a door, but like using a bulldozer to do that. It's just, energy overload. So your body has to break down these macronutrients into smaller pieces, which the body can use. So it starts there. That's called mechanical digestion. And as you swallow food, the food has now turned into something called a bolus, and it's going to make its way down the esophagus. And the esophagus undergoes involuntary contractions called peristalsis, which delivers the food to the stomach. So involuntary, which means as soon as you swallow your food, these rhythmic contractions, you don't have to think about. You don't have to like flex your esophagus, right? You don't have to tell your esophagus to, hey, please deliver my food to the stomach. It would just do this on its own through something called peristalsis. So your food would then exit the orifice that's here, this sphincter, and then it makes its way into the stomach. It's this pouch which has hydrochloric acid, and it also secretes an enzyme called pepsin, which works at low pH, and pepsin helps digest proteins. So once all this food has been broken down in the stomach, it's going to make its way past the pyloric sphincter and into the small intestine. Now, before I get to the small intestine, let me just point out there's a few auxiliary organs here. The liver, which has the gallbladder seated underneath it. So the liver produces bile, and it is then stored in the gallbladder. So as you're digesting food in the stomach, the gallbladder will secrete this bile, which is a chemical that helps break down fat. And then underneath the stomach right here, you have the pancreas, and this will secrete insulin and glucagon, which helps with the absorption of sugar. All right, so once food passes through the stomach here, it's going to make its way into the small intestine. Now, it's kind of a misnomer, and it always throws people off. The small intestine is actually, it's quite long. So if, for example, you got disemboweled and people were to stretch your intestines out, it would be roughly like 20 to 26 feet. Okay, and it's kind of like wound up like this. So this is where more absorption occurs. We'll talk about the villi and how nutrients are taken up by the small intestine. Okay, and so it's going to make its way around this 26-foot long organ before the remains get passed on to your large intestine. Now, it's called the large intestine because I would assume it's wider. Okay, and that's why it's called the large intestine, not because it's longer. Okay, and so as your food has now been broken down into bits, okay, all the pieces that were unused will travel through the large intestine where more water gets reabsorbed. And then finally, any waste products will then, that's why you go to the bathroom soon after. So yeah, that's the process of digestion. So from top to bottom, in summary, mechanical digestion occurs in the mouth. Carbohydrates get broken down first, goes down through your esophagus into your stomach, where the stomach secretes pepsin, which breaks down protein. And then you have these 3 auxiliary organs here, which aid in the digestion of the macronutrients that we discussed earlier. Then it passes to the small intestines, where absorption occurs, and then into your large intestines, where water is reabsorbed, and then that's where the waste is then ejected. I want to illustrate to you how nutrient absorption occurs in the small intestine. So we zoom in, we can take a closer look. Okay, so this is the inner wall of your small intestines, and you can see there's a lot of these like finger-like projections here and a lot of folds. These are called villi, and the villi help increase the surface area so that you're getting maximum nutrient absorption all throughout your small intestine. So if you really zoom in here, okay, here is what a villi looks like. It's that finger-like projection. And you have the interior of the intestine that's here. So you have your blood capillaries and your lymph vessel lined underneath your villi here, your villus. Okay, and this is zoomed in a lot. These are really small. So as you're soaking up these nutrients, it's then going to travel to your blood cells, your blood vessels, which are then they contain blood cells that help deliver these nutrients throughout the rest of your body. So that's kind of like an overview of your absorption. Okay, and then do note how you have these blood vessels, okay, that are wrapped around, or they connect to your intestine. So that's how nutrients are delivered. Okay, so your digestive system is connected to your circulatory system, and these nutrients will then travel throughout the rest of the bloodstreams through, major arteries and veins. Just real quickly, we'll take an in-depth look at some of the things that I've already discussed. So digestion occurs in the mouth. We know that. That's mechanical digestion with your teeth, breaking down the food. Chemical digestion is through the amylase that's secreted by the salivary glands, which helps break down starch into simple sugars. So as you swallow your food, you can see here this is called the bolus, and it just travels down the esophagus through peristalsis, so the involuntary contractions that we mentioned earlier, and then it then gets plopped right into your stomach. Your stomach continues with this process. It secretes digestive juices, and it turns this bolus into a liquid mixture called chyme. So then your stomach does its job with breaking down proteins through secreting the enzyme pepsin. And then finally the stomach will empty into the small intestine, and the small intestine has a few parts to it. So it starts with a duodenum, and then you have the section called the jejunum, which is the longest section of the small intestine. This is where the absorption occurs. And then this small segment here is known as the ileum, which empties into the cecum of the large intestine. So if you just follow the cursor here, I would imagine that the food just kind of wraps around the small intestine this way, all the way around 20 to 26 feet of small intestine into your large intestine there. So the remains of the food is then passed through your large intestine. This is where water gets absorbed and solid waste is eliminated by the large intestine. So the large intestine, sometimes it's called the colon, absorbs about 1 liter of water per day, and it also contains many types of bacteria. Here's an overview of the excretory system. So the excretory system eliminates non-solid waste from the body, so through sweat, urine, and exhalation. So this is how you can maintain homeostasis, because you don't want toxic materials like, too much water or salt or carbon dioxide, urea, minerals and vitamins, metabolites, things to build up in your circulatory system. So then you have to remove it through the excretory system. So the lungs remove excess CO2 and water vapor through exhalation. Your skin will release excess water and salts. Your kidneys are responsible for filtering the blood, and any excess water is then passed off as urine. So here are your kidneys. You have a pair of them. They're a bean-shaped organ located on your posterior side, so your back side here. And you have a ureter that connects to the kidneys here, and this is the tube that carries urine down here to the bladder. So the bladder is a sac-like organ, and it stores about half a liter of urine. And then urine is then passed through a tube called the urethra. So the parts for boys and girls are a little bit different, but everyone has these here. Okay, the kidney, the ureter, and the urethra. Now when you zoom into the kidneys, okay, you could see that it has a cell called a nephron, or a part called a nephron. Here's one nephron here, and you could see how any unfiltered blood, you have a bunch of like capillaries passing in through this thing called a glomerulus, and this is where the filtration occurs. Filtered blood then rushes out, and then any excess water will then travel through the tubules here, and then the urine then connects to your ureter, right? So, right, they're zooming in to one part or one nephron here, and it's going to filter your blood, and then any excess water is then passed out of your ureter here. So you can see the ureter connecting, and then the urine will then make its way down towards the bladder. All right, so not only do your kidneys remove waste products from your blood that are produced during digestion and cell respiration, it helps maintain the right amount of electrolytes, pH, and fluid in your body. So your kidneys will also release hormones that help keep the bones healthy. In a way, it's involved in making red blood cells, and it helps regulate blood pressure. So the kidneys contain filtering units called nephrons, which we discussed earlier. And there are about 1 million of these nephrons here, and it helps filter about 180 liters of blood every day. And about 1% gets excreted as urine, okay, which is mostly water content. So you might run into problems with your kidneys where they're not doing their job efficiently. So let's say you don't have a pair of functional kidneys, or they're not working properly. You have a low quality of life where you have to undergo something called dialysis, where you go to a clinic and they hook you up to a machine that filters your blood. But this process takes about 6 to 8 hours at a time, and you have to go several times per week. Now, you do have the hope of receiving a kidney from an organ donor, because remember, everyone has a pair of kidneys when they're born. So these organ donors could be relatives or friends, and they decide to give you a kidney during an operation here. Your kidneys can also produce something called kidney stones, which are insoluble products that build up on the inside of the kidneys, and this causes a lot of pain in your abdominal area. And kidney stones build up as a result of just poor diet. You're eating processed meats that contain a lot of preservatives and other chemicals that they throw in there. And the only hope of getting this pain or getting the kidney stone out is passing this through. Okay, so you can kind of imagine how that feels. So there's some treatment for this, like shockwave therapy, where they use ultrasound to break up these kidney stones, or you can just wait to urinate this thing out. So I would imagine that's really painful. So just to show you what kidney stones look like, okay, again, these are basically pebbles or rocks that form on the inside of your kidneys, and these are insoluble, which means they don't dissolve in water. And again, if you look up what's on the nutritional label of things like Red Bull or like hot dogs and stuff, you have things like oxalate, calcium carbonate, things that don't dissolve in water, which are found in these types of products that you consume. So a good healthy diet is needed to avoid issues with kidney stones, because your kidneys are important. Again, it filters your blood and it removes waste products and it passes it through urine.